Right, so here we want to be clever. We want to make sure that we check first, and our checking is going to be obviously we continue to look at these as we approach infinity. Okay, so now we first are going to check that if we put infinity here and infinity, we get something like infinity over infinity. Okay, so now I've removed that set that we had here so that we can see if we can remember. Okay, so now here we have infinity over infinity. Okay, so what do we do with this one? There's nothing much that we can do here. There's nothing much that we can do. Where it's not apparent in terms of what we can do, what if for example I was to multiply by let's say I want to clear the x and the x squared. If I multiplied by, let's say, 1 over x squared, here quite all right, I'll clear. But here, when this one goes inside the radical, okay, under the radical sign, we're going to have a problem because this will be power 4, right? Power 4, here power 4, here power 4, then we'll still have a problem inside this radical, okay? We won't be able to tell the full story. So now what do we do here, right? What we do is we try to form this into a single fraction and then see what happens. So I'll ignore this, but I'll put it back later, okay? So I'm going to put this one under, I'm going to put this one under radical sign, right? And then I'll divide with this one under the radical sign as well. Okay. Now, what else can happen here? What else can happen is that we can now create this, because normally we don't want to use them in this format. So we are going to expand this one. Okay, we're going to, and this is the square of this factor. So we can say that it's x squared plus 6x plus 9. Okay. Now, this one is going to be maintained. Okay. Now we say that if we have two radical signs, we say that if we have a and then we have b, we mentioned that we can still consider these as ab. Or if we have this and this, we can consider those as a over b. It's not different from this. So we're going to have x squared plus 6x plus 9 over 9x squared minus 5x, like that. Okay, hope that we are following. Okay, now we're going to continue from here. We say that now, because this is a fraction inside this, it's the same as if I had, let's say I've got a square root of 9 over 4, right? I can find this fraction like this, or if I were to, let's say I multiply by 4, I would still have, I can still multiply 4 here and 4 there and still maintain the integrity of this. I'll have 36 over 16, right? So if I find the square root of this, the square root of this will be 6 over 4, meaning I can reduce this to 3 over 2. I can still use that same one. You see, here I can still say this is 3, this is 2, which will be same to as that one, which is similar to this, right? I can multiply with same number or same element, Okay, and then I have 9x squared minus 5x. Right, so I look for the highest power, then I say 1 over x squared, then 1 over x squared. It's just patterns as always, okay? So now this one will be what? This one will be, this and that will give us 1. This and that will give us plus 6 over x. This one will give us what? Plus 9 divided by x squared. Okay, and then here we are going to have 9. Okay, because x squared and x squared will cancel. Then we'll have 5 over x, but all under a radical sign. So now we can bring our notation here and say it's like this. Okay, so now what happens when we replace the values? What happens when we replace the values is that here we're going to have 0, because you have to remember that we said that 1 over infinity should give us 0, or any number over infinity should give us 0. So infinity, infinity there, this is 0 and that's 0. So we'll have 1 plus 0 plus 0 divided by 9 plus 9 minus 0, okay, based on the same assumption, right? So now this one will be 1 over 9 square root. So eventually we find that the limit is going to be 1 over 3. Okay, so that'll be as simple as that.